This is a continuation of our discussion of the polynomial functions with a degree of 3 or more. And I want us to actually look at some examples of how to use all that information that we just discussed. So we're going to jump right in. Okay, so here's our example. We have negative 4x to the third plus 4x squared plus 15x. And so the first question says, what is the degree of the polynomial function? Well, remember, the degree corresponds to the highest exponent. And in this case, the highest exponent in that particular function is 3. So my degree is 3. The leading coefficient is the number in front of that highest degree. So my leading coefficient, which we represent as a sub n, would be negative 4. Then I want to use the leading coefficient test to determine what the graph looks like on the extremes. What is it going to do on the left side and the right side? And so if I look, I have an odd degree and my lead coefficient is negative. So if I go back and look at those options, I believe that we would find that it's going to rise on the left and fall on the right eventually. So eventually it's going to go up on the left-hand side and down on the right-hand side. The next question asks us how many turning points we could have with this graph. And the formula is at most n minus 1 turning points. Well, in this problem, n is 3, and 3 minus 1, n minus 1, 3 minus 1 is 2. So that tells me that I'm going to have at most 2 turning points. Now remember, at most means it could be 2 or less. Okay, at most means 2 or less. Then it asks me, according to the leading coefficient, according to the fundamental theorem of algebra, how many zeros could the polynomial function have? Remember, the rule or the guideline there says you're going to have exactly n. So it's equal to the degree. So we would have exactly 3 zeros. Now, I don't know whether those zeros are real or imaginary. So I can go off over here to the side and use Descartes' rule of signs to help me decide. I can determine how many of them are going to be positive, real, and how many are going to be negative real. Okay, so to determine the positive real, I'm going to go back to the original problem as it was given to me, negative 4x cubed plus 4x squared plus 15x. Okay, so we start out with a negative, so we go from, it's a negative, then a positive, then a positive. So when I go from negative to positive, there's a sign change. Positive to positive, that is not a sign change. So there is only one sign change, which means I could have at most one positive real zero. To decide about the negative real zeros, I have to take and substitute in place of x, I have to put negative x. So I'm going to do that right here to the side. I would have negative 4 times negative x to the third plus 4 times negative x squared plus 15 times negative x. Okay, so negative x cubed, remember that's literally negative x times negative x times negative x. So I'm going to have negative 4 times the opposite of x to the third plus 4. Negative x times negative x is just going to be x squared plus 15 times negative x is minus 15x. So I have negative and a negative, so I have 4x cubed plus 4x squared minus 15x. That's my final answer. And so then if I go back and I look at those sign changes again, I go from positive, positive, negative. Positive to positive is not a sign change. Positive to negative is a sign change. So I also have the possibility of having one negative real zero as well. Okay, so now I have a sense. I know I should have 3 zeros. I could have one positive and one negative. And so then I'm going to move on. And the next question asks me to find the y-intercept. To find the y-intercept for any function, we let x equal 0 and solve. So I would have f at 0 equals negative 4 times 0 cubed plus 4 times 0 squared plus 15 times 0. So I have negative 4 times 0 plus 4 times 0 plus 0, which gives me 0 plus 0 plus 0, which is 0. So my y-intercept, written as an ordered pair, is 0, 0. Then it asks me to find the zeros. Well, in some cases, the polynomial can possibly be factored. So the first thing we want to ask ourselves is the polynomial, factorable? Can it be factored? If it can, that's the route we're going to take. If it can't, then we have to have an alternative. I believe this particular one will factor. If I go back up here to the top, right next to it, I realize that I have an x in common all the way across. I'm also going to take out a negative. Okay, so I'm going to take out a negative x, and I have 4x squared minus 4x minus 15. So I have negative x, and then I need to factor the trinomial. Again, you can do that using a variety of techniques. I tend to do it by trial and error. So I have 2x and 2x. Let's see if I do a 5 and a 3. That gives me 10 and 6. So I have a negative x, 2x plus 3, and 2x minus 5. And so I know that one of those pieces had to be 0. So I know that negative x could have been 0, 2x plus 3 could have been 0, or 2x minus 5 could have been 0. And so if I solve each of those respectively for x, okay, so I divide by negative 1. So I have x equals 0. I have negative 3 from either side. 2x equals negative 3. Divided by 2, divided by 2. So I get x equals negative 3 halves. And then add 5, add 5. 2x equals positive 5 divided by 2, divided by 2. So x is 5 halves. Okay, so x equals 5 halves. And we said earlier we should have 3 zeros, and I have 1, 2, 3 answers. Okay, then eventually what I want to do with all this information is I want to try to create just a basic idea of what this graph or what this particular polynomial function would look like. So I'm going to rough sketch it here. All right, so let's see. We know that our y-intercept is 0, 0. We also know that we have a 0 at 0. We have a 0 at negative 3 halves. And we have a 0 at positive 2 1/2. We also know that eventually over here on the left, it's going to go up. And we know eventually on the right, it's going to go down because of the leading coefficient test. So I need a sense of what's going to happen here in the middle. And quite honestly, the only way to do that is going to be to pick a point and plug and chug. So I need to get an idea of what's happening between 0 and 1 1/2. So maybe I'm going to come off over here to the side and I'm going to figure the value for negative 1. It's a straight plug and chug. Negative 4 times negative 1 cubed plus 4 times negative 1 squared plus 15 times negative 1. So I have negative 4 times negative 1 plus 4 times 1 minus 15. That gives me 4 plus 4 minus 15. That's 8 minus 15, or negative 7. So at negative 1, I'm going to be down here at negative 7. So I know I'm going to come down to this point. At some point, I've got to curve back up because I had to go up here and hit my 0. And then I need to figure out what's going to happen between 0 and 2 1/2. So I'm going to figure another point with plugging and chugging. And I want to pick something easy, so I'm probably just going to pick 1 again. And I would have negative 4 times 1 cubed plus 4 times 1 squared plus 15 times 1. So I have negative 4 times 1 plus 4 times 1 plus 15. So I have negative 4 plus 4 plus 15, which is ultimately 15. So I'm going to be way up here at 115. Okay, and so my graph is going to come up, and it's not perfect, okay, but we're not trying to be a rocket scientist. We're just trying to get a sense of what it looks like. And you can always double check yourself by plugging it into the calculator. And I do have 2 turning points where I changed direction, so I'm within the guidelines, so I'm good to go. There it is. All right, let's look at another one. I want to look at a different one this time where we have an even degree, and I got these out of order, so let me fix the slides. Okay, and so this is a second example where we have an even degree. So the first question again asks us what is the degree, which is your highest exponent, which is 6. It asks us for the leading coefficient, which is the number in front of that highest exponent. Remember here, there's an understood 1 there. So my leading coefficient is positive 1. So I have an even degree and a positive leading coefficient. And so if I go back and look at the rules for the leading coefficient test, you may want to make notes about what those 4 options are. It's going to rise on the left and rise on the right. So eventually it's going to go up on both sides. The number of turning points would be at most. Okay, and then remember, you got to do a little calculation here. You got to do the degree, which is 6, minus 1, which is 5. So we have at most 5 turning points. And then the fundamental theorem of algebra tells me I'm going to have exactly 6 zeros. And then I'm going to use Descartes' rule of signs to get a sense of how many of those are positive and how many of them are negative. For positive, we go back to the original problem and we count our sign changes. We have plus, minus, plus. Okay, so if we count our sign changes, we have from plus to minus, that's a sign change, so there's one. Then we have minus, back to plus again, so there's another one. So we have a total of 2 sign changes, so that means we could have 2 or 0 positive values. To decide whether or not I'm going to have negative zeros, remember you got to substitute negative x into the original function. So I would have negative x to the 6th minus 3 times negative x to the 4th plus 2 times negative x squared. Okay, so if I do that, I'm going to have positive x to the 6th minus 3 times x to the 4th plus 2 x squared. So I have it all solved out, and again, I'm going to count my sign changes. Okay, so we go from positive to negative to positive. So from negative to negative, there's one. From negative to positive, there's another. So I could have 2 or 0 negative. And you may say, well, Miss Ralston, that only totals to a possibility of 4, and I'm supposed to have 6. That probably is a clue that I have 2 solutions that are imaginary. So let's continue. Next, I want to find the y-intercept. And again, to find the y-intercept for any function, you let x equal 0. So if I sub 0 into the function, I have 0 to the 6th minus 3 times 0 to the 4th plus 2 times 0 squared. So I have 0 minus 3 times 0 plus 2 times 0, which gives me 0 minus 0 plus 0, which is 0. So again, in this scenario, my y-intercept happens to be the origin. It would be 0, 0. Again, as I look at this problem, it does appear that I can factor this particular polynomial. I notice that I have an x squared in common, so I'm going to factor that out. I have x to the 4th minus 3x squared plus 2. And then I believe I can factor that. I'm going to go this way. I have x squared, and then I'm going to break down the polynomial inside the parentheses. I would have x squared and x squared, and 2 and 1 would add to 3, and they're both negative. So then I know one of those pieces had to be 0. So either x squared equals 0, x squared minus 1 equals 0, or x squared minus 2 equals 0. And if I solve each of those respectively for x, I'd have to take the square root. So I have x equals technically plus or minus 0. Add 1 to each side, and I get x squared equals, excuse me, I got ahead of myself. X squared equals 1. And then I'm going to square root both sides. So I have x equals positive or negative 1. And then finally do x squared minus 2. I'm going to add 2 to either side. So I have x squared equals 2. I'm going to square root. So x equals plus or minus square root of 2. Okay, so we actually have 1, 2, 3, 4, 5. We actually do come up with 6 solutions because the 0 actually occurs 2 times. So we say it has multiplicity of 2. You have positive 1, you have negative 1, you have square root 2, and you have negative square root 2. So ultimately, we do have 6 answers. And then again, we want to try to create just a really rough sketch, okay? It doesn't have to be anything super, super perfect. You could also plug it into your calculator and get a sketch. Let me see what I can do here. Okay, we know that we have a the y-intercept is at 0, 0. We also know that we have 2 zeros there. We have negative 1, positive 1. We have square root of 2, which is about 1.4. And we have negative square root 2, which is 1.4. And we know eventually on these ends that it's going to go up on both sides. So I may need to get an idea of what's going on in between those points, and it's going to get really messy. Okay, so what I might do then is just go out to my graphing calculator and get a picture. I would anticipate, I don't know exactly, but I would anticipate it does something like this. Okay, let me see. So again, if you can factor the polynomial, it's a great way to do it. If it doesn't factor, then you may need to do something else. And I want to look at that something else again in a separate video because it's rather lengthy.